On this week's UBC From Here, recognizing a rising academic star.
I'm really passionate about forensic psychology because I had joined the debate team in high school, and so law was always a passion of mine, and it just so happens that there was a wonderful psychology program here, which is what I was going to do my degree in, and it happened to combine both of my interests.
Building international leading-edge collaboration.
What we're doing with Phil, and what we're doing together I should say, is trying to work out the mechanisms responsible, or that link exercise to cognition. And one theory, which is evolving, is that it's a hemodynamic thing, that it has to do with blood flow to the brain.
And finding new ways to recycle and reuse industrial waste.
When I started in 2009 as an assistant professor here, I wanted to do work with some local industries and went to see what are the challenges are and what are the problems, whether our expertise could help them mitigate those.
Hi, my name is Austin Exeni, and I'm a second-year management student here at UBC's Okanagan campus, and welcome to this week's UBC From Here. Each year, faculty identify an undergrad as the Undergraduate Student Researcher of the Year. This year, a fourth-year psychology student received the honor.
So this research that I'm doing is very important. It has huge implications in the criminal justice system. Eyewitness testimony is a very powerful piece of evidence. So if somebody stands up in a courtroom and they say, I saw this person do that, that's very compelling. It's very enticing to want to believe them. But I think we need to take a step back and think, well, how accurate is that memory? Is there any details that could be incorrect about it? And so that's what we're hoping to understand, is how these emotional, intense events that we're trying to recollect and recall fall apart, and when they're strong, and when we can rely on them, and when we can't. My name is Udala, and I'm a fourth-year psychology student doing an honors degree specializing in forensic psychology, and I'm really honored to be selected as the Student Undergraduate Researcher of the Year. I really enjoy being able to find things out about human behavior and why we do the things we do and what it is that we really know. And in terms of memory, I'm really interested in what we don't remember sometimes, and also what we falsely remember, things that didn't even actually happen. I'm really passionate about forensic psychology because I had joined the debate team in high school, and so law was always a passion of mine, and it just so happens that there was a wonderful psychology program here, which is what I was going to do my degree in, and it happened to combine both of my interests. And to be able to do work on memory was also very appealing to me because I've heard a lot about eyewitness testimonies and false confessions and the things that can go wrong in the criminal justice system. And so that's something that I wanted to pursue in my degree. I think it's because I am a very curious person. I really want to know a lot about human behavior and the mind and how it works. And I find the research to be a high caliber.
Megan has been a delight to work with, and she's been one of the best students I've ever had in my 14 years as a professor. She is really, really bright and motivated, and she's contributed more intellectually to the studies that she's been doing than any undergrad student I've ever worked with.
In the UBC Okanagan Psychology Department, they really support student learning and student experiences. We take part in doing honors degrees, which involve completing and writing your own thesis and conducting a research project on your own. The focus of my research is on the strength and fragility of memory, looking at emotion and how it affects general memory accuracy.
Megan exemplifies the researcher practitioner or the science practitioner model that we really advocate in psychology. She's a brilliant researcher. She can, work in the lab from dawn till dusk, dusk till dawn, and collect her data and, interpret the data in a way that's meaningful for the scientific community. But then she's also able to bring that to the real world.
I hope that I can continue on this line of research. It's an exciting area in which I hope to continue to study. I did apply to graduate school, and hopefully I hear some offers back from that. And so I would like to continue researching in the area of psychology, and also potentially being a clinician and actually working in the field.
International collaborations continue to flourish between UBC researchers and their colleagues from all around the world. One such collaboration is creating leading-edge cardiovascular and physiological research.
Dementia is a very rapidly growing chronic disease issue in the Western world. People are living longer. People are also less active physically than they ever were before. And that combination of things can lead to, and I think has led to, an increase in the prevalence of dementia. There are no current drug therapies. You can't take a pill and fix your brain at this point. But there's some very promising research that suggests that exercise is an intervention which does protect your brain and your ability, your cognitive capacity. I'm Daniel Green. I'm from the University of Western Australia. I'm in the School of Sports Science, Exercise and Health. I also have a position in Liverpool in the United Kingdom, where I'm the Professor of Cardiovascular Physiology. What we're doing with Phil, and what we're doing together I should say, is trying to work out the mechanisms responsible, or that link, exercise to cognition. And one theory, which is evolving, is that it's a hemodynamic thing, that it has to do with blood flow to the brain. And there's some promising evidence that the heart and the brain are linked in this way, that if you have a healthy cardiovascular system and you have good cardiac output and your blood pressure is well controlled, then your brain is protected.
Phil Ainslie, I'm a professor in the School of Health and Exercise Sciences. It started notionally about 8 years ago. All our work is in how blood flow gets to the brain, and lots of Danny's work is in how blood flow gets around the body. So we collaborated on how to measure blood flow, and he's helped us out a lot over the years to be able to do that using non-invasive methods. So we built that relationship over the last few years, and we've been involved with some grants to look to see how exercise training might impact on cardiac blood flow and also blood flow to the brain, especially in people who are at risk from dementia.
Where we were able to help him with some technology and building some equipment and research capacity when he came to Okanagan. And he's been very helpful for us also, because his expertise is in measuring blood flow to the brain, and that's something that we couldn't do. So it's been a very effective two-way street in terms of collaboration, and it just goes to show, you know, what can be achieved when people get along and when their labs are doing work that is synergistic.
Hi, and welcome to this edition of UBC's Next Big Thing. I'm Rosemary Jean Thompson. Today my guest is Dr. Shahriar Alam, assistant professor with the School of Engineering here at UBC's Okanagan campus. And he has done research around industrial waste recycling. Tell me a little bit about that.
When I started in 2009 as an assistant professor here, I wanted to do work with some local industries and went to see like what are the challenges are and what are the problems, whether our expertise could help them mitigate those. In the Okanagan Valley, there are more than 40 composite manufacturing companies. They produce lots of fiberglass scrap, like about more than 1,000 metric tons, and they need to go to landfill, and they are not biodegradable. They have to pay environmental fees to dump it in at a distant landfill. So we wanted to see like how we can utilize it. And also there is another problem in the whole Canada, like 40% of Canadian civil infrastructure, they pass their service life and they need to be demolished for new construction. And they produce lots of construction demolition waste.
And where does that go? Where does that waste?
They also need to go to the landfill.
Okay.
A major portion of it, about 50%, is concrete. And that will actually take up huge amount of space into the landfill, and they'll be just sitting there idly until they disintegrate. And
So it doesn't break down,
no,
concrete. Once it's concrete, it stays like that.
Yes. So that takes huge hundreds, thousands of years.
Wow.
So what we wanted to do is we have two different waste, and we want to see like how we can utilize it and give it some values. We talked to some local industries like Shake. They produce glass fibers, and they produce lots of waste. So that's definitely a concern for them. And City of Kelowna, they administers the landfill, Glenmore landfill. If we not utilize this concrete waste, their space will be very soon filled up. So that's also a concern.
So what did you do to bring these two waste pieces together?
We wanted to use it as an aggregate. It means for concrete, for producing new concrete. So you know concrete is made of cement, water, sand, and aggregate, coarse aggregate, which is gravel or stone chips, you can say.
Right.
So we wanted to replace that portion because that actually constitutes 70% of the whole volume. We want to replace it with recycled concrete or fiberglass scrap. We cut them into small pieces and we broken the recycled concrete down into the pieces what we should use for aggregates, and then we replaced it. So we replaced separately as recycled concrete and glass scrap, and also we combined them together. And we found that they can be utilized to produce industry quality concrete.
So you created a new concrete product
Right.
out of waste, out
Right.
of these two different products. Now I know you've come up with this new process for recycling concrete, but you've really tested it quite thoroughly. Maybe you can explain that.
So the way we tested is, for example, when we replace natural aggregate with recycled concrete, that we call it first generation concrete. That concrete structure will again pass its service life, and we want to see whether we can again utilize it, and when it will be demolished, we can utilize the aggregate again. We tested first generation, second generation, third generation that way. Under various environmental exposure, we tested its strength, and it was remarkably found that the first generation with 100% replacement could perform the same way as regular concrete. And even the second generation, the strength-wise and performance-wise, it was very good. It can be utilized. But the third generation, there was a little bit of problem in terms of strength to achieve the target strength within the days. But eventually, after 120 days, we found that it could surpass the target strength way beyond.
Wow.
And the performance under various environmental exposure, it was also very good.
Wow, so this is like concrete that just keeps on going. Keeps
Exactly.
on going, and,
Yes.
and it's been tested up to 3 generations. So you found that worked. It was tested in the lab here,
Right.
which is awesome with some of your students.
Yes,
on
some of my
campus.
students, some graduate students, undergrad students, they were highly instrumental because that involves huge amount of work. So without their effort, it was simply impossible. Also through our research, we wanted to make sure like we just publish research paper and it stays there.
Right.
We wanted to see it really being implemented by industries. So we talked to some local ready-mix companies. So OK Builder Supplies Limited, they were very much interested.
Okay,
to-
building supplies, right?
Yeah, OK Builder Supplies. So they really wanted to bring a green product into the market. We have to test because industry, there's always a fear to bring a new product. They wanted to make sure like its strength is adequate, it can hold up under various environmental exposure. You know, in Canada we have freeze-thaw cycles. We use lots of salt. That actually increases corrosion. It's a chloride environment, increases the corrosion
Right.
of rebar inside. And also in several parts of BC, we have sulfur in soil. So it had to go through some
Withstand
sulfur
that.
exposure.
And it did. That was the
Yes.
good news.
Yeah, so it was able to withstand all these various environmental exposure, and industry people were really satisfied with the performance. Eventually, it was brought after 3.5 years, 4 years research. They finally agreed to bring it to the market. So the first application was in June 2013.
And that was in a house.
And that
house
was in
being
a
built for the
residential house
foundation.
for foundation and structural wall. Yeah.
Great. So the industry's interested, which is great news. It's always
Right.
fabulous to hear that when
Yes.
UBC researchers are doing something, it's actually looked at as something that's good for the environment and
Exactly.
good in the community. Shahriya, thank you so much for coming and talking a little bit about your research. I'm sorry we couldn't touch on it more, but
Right.
we'll have you back and we'll find out how we're doing with this recycled green concrete.
Thank you for the invitation.
And that wraps it up for this edition of UBC's Next Big Thing. Until next time, I'm Rosemary Jean Thompson.
That's it for this week's UBC From Here. For more stories from the Okanagan campus of UBC, visit ubco.tv. I'm Austin Ixeni, and thank you for watching.